Thanks a lot for this nice introduction. It's always a pleasure for me also to be here. And today I selected a topic which drives me for quite a while now. It's about platform engineering. I tried to figure out a way to talk about it that probably fits this audience, so I will not go so much into technical details as I sometimes do on this topic. And I was talking at Agile Tour a few years ago about micro-frontends, I think, to kind of enable verticalized teams. And I think the title was actually quite similar. And we'll talk about platform engineering and how we can basically support autonomous teams or the success of autonomous teams by it. And initially, I wanted to end this talk title with a question mark. But you probably know better Rich Slow, right? Which says that everything that ends with a question mark is probably to be answered with no. And I didn't want to make it that easy for us if platform engineering really has an impact on how we can design our autonomous teams successfully. My name, as Raul said, is David. I consider myself as a principal engineer for a company called Square. I'm one of the co-founders of this company a few years ago, and you probably don't see me that much in Vienna these days anymore, and this is a simple reason that I shifted my focus a little bit more on the Munich branch these days, a couple of months ago. And yeah, but I'm always happy to be here and to see a lot of familiar faces. And when I was thinking about this talk, I do a small podcast called The Engineering Club, and one of the guests was Ted Neward, and I talked with him also in the pre-discussion a lot about platform engineering and in general about abstractions and layers and all the stuff we have in our industry. And probably you know Ted Neward from various talks, and he basically said there's no other industry out there that is as good as introducing abstractions as we are, right? So obviously, yes, we're the best in something, introducing new layers. And that's quite interesting because if you think about it, it's obviously true, right? Everything started with zeros and ones, and you know, we introduced assembler, and we introduced operating systems, we introduced compilers and virtual machines, and we basically introduced a lot of frameworks in the last, I would say, last couple of decades. And if you think about this, this is quite at the pace, right? So if you think about Alan Kay, who introduced Smalltalk, which was basically, I would say, the first high-level language in which provided us with this developer experience, then he could potentially be my grandpa, right? So you see the amount of time that has flown over there is not that long. And if you think about this, of course, this is not the last thing we will see, right? And currently we probably see with LLMs and prompt engineering, you know, maybe the next step of compilers where we don't need to be that concrete anymore because, you know, the machine is just getting clever in understanding what we want from it. And this discussion was kind of interesting because we, of course, understood the more layers, the more abstractions, the more easier our life should get, right? And if you take a look at the morning keynote, we talk a lot about cognitive load, mental load these days, and it seems to be one of the biggest challenges we have there, right? To kind of, you know, be able to kind of put this all in our head that's out there when we do our daily job. So how could it be if we add abstractions by abstractions to make our life easier? And one of the reasons is, of course, that our software systems over the last couple of years came a lot more complex. We started with simple monoliths, and we went into distributed systems, which we then want to horizontally scale, being more elastic, right? Which we should be able to deploy every few days, every few minutes, every few hours. Usually these days, they should be resilient, they should be decoupled, right? And they should be easy to extend. So there's a lot about those architectural changes we did, especially over the last couple of years. And if you think further, then we see first organizations, splitting up microservices into even smaller things, which of course increases again our mental load, I would say. And this talk, which I mentioned before at Agile Tour in 2019, it was we talked about cultivating architecture in an agile world. And I brought up this slide from the DevOps report back then. And it was very obvious back then already that operational performance is, of course, highly coupled to continuous delivery, and continuous delivery is, of course, highly coupled to leasely capital architectures. And I think now, fast forward nearly 5 years, everybody, I would say, in our industry understood that we are not building these distributed systems as an architectural style, but they are basically more about scaling our teams, our organizations. So they are basically an organizational scaling strategy. And I don't have so much dogma about the term microservices because it's very ubiquitous these days. But basically how we slice our architecture has a lot to do with how we want to basically make our organizations more performant. And this, of course, led us to the well-known Werner's "you build it, you run it," right? Which is basically saying teams have more autonomy and have more accountability. So you can build it the way you want it, but you also need to run it. Right? And this, of course, is not always handy for us, and I think this is very important to understand that you could also be somewhere in the middle. You build it, you own it, you build it, you care it. It's important just that you stay somewhere on this middle line, right? Because if you go too far into one direction, then, devs will quit you, because you cannot expect from devs to run the system if they are not kind of autonomous enough to build it to their needs. And of course, you can also not do it the other way around to say, hey, you can do whatever you want, but in the end, somebody will run it for you. Right? And this is actually what we tend to call shift left these days, right? We say, hey, you as a development team, you're not only just building this stuff, but you're also running it. And we see shift left quite often in our industry back in the days. So this was not the first time with DevOps in 2009 that we introduced such a shift left into the development teams. But if you, for example, think about project management, right? And we're here at AgileConf. So basically what we did with the Agile Manifesto in 2001 is saying, hey, we put this thing more to the teams, right? We decentralize this more. We make them more agile in that sense that they can faster react on changes. And the same thing happened for product engineering, right? If you think about domain-driven design, Eric Evans in 2004, or for example UX or customer experience, where back in the days Alan Cooper, I think in 1992 or so, introduced personas to our industry. It was nothing else than saying, hey, you developers, you teams, you need to be more aware of the customers, you need to be more aware of the problem domain, right? And of course, we could prolong this list for quite a while, but quality assurance and testing, right? Ken Beck, 1997, introduced basically X units to give us as developers the possibility to at least a portion of what we do are able to test. So there's a constant shift left in our industry, which makes us faster, we could consider, right? Which breaks down boundaries. We could now do a lot of stuff which we usually distributed across multiple teams back in the days. But of course, it also has a heavy increase on the mental, on the cognitive load which we see in those teams. And the good example is, of course, or the most well-known example these days is the cloud-native landscape, right? So I'm not sure if you know this picture, but even if you have a 36-inch display these days, you will not be able to see all the logos there anymore, because obviously there is so much happening in this area of cloud infrastructure and cloud-native infrastructure especially. And the strategy, as I said, was simple, right? We say, hey, we have all this stuff. Obviously, you all need all this stuff, so, just take care of it, right? And that's what we tend to call shift left. And I usually call this pile left, right? Because that's what we're doing. We pile up all this stuff on the development teams. And of course, at some point in time, they will not be able to handle this anymore. And I think especially in the field of cloud-native infrastructure, we see this very good. So what's the answer to this, right? As I said in the intro, layers, right? So the fundamental theorem of software engineering, probably you know it, or you can look it up on Wikipedia, but it basically says we can solve every problem by introducing an additional layer. I mean, often the asterisk at the end of the sentence is lost, right? Which says, besides the problem of having too many layers, but that's basically the idea we had, right? And usually we tended to just call this a platform. right? So we hide away the complexity from those underlying tools to make the teams, reduce their cognitive load that they need to take care of that. So why a platform? Why should anybody build a platform on its own, right? There's a lot of good platforms out there from hyperscalers like AWS, GCP, Azure, and of course others. So what's the value of not so many companies building their own platform for the developers? So I think the answer is quite simple and reasonable. We say, we as an organization know much better what we potentially need, right? We can say, hey, our developers are usually building applications, and they consist of a Spring Boot service, they consist of a Postgres database, they consist of publishing or consuming something from a Kafka topic. And this, of course, gives this platform, which is built for an organization, a competitive advantage, I would say, right? And it's quite interesting if you talk to different engineers in different organizations and say, hey, I want to have a new service, then at organization A new service consists of total different things than in organization B. So there seems to be this kind of, how Gregor Hope usually tends to call it, this technical domain language, where service in the organization is usually a defined thing, where in 80% of the cases we structure it the same way. And this is the idea of building those platforms. But those platforms, I would say, historically have a big problem. That they need to fulfill different needs, right? For a developer, they need to, first of all, enable innovation so that we get faster pace on delivering features, faster pace on trying out things, right? So in general speed. For classical operations team, it was always kind of, reusage, it was kind of standardization, and it was kind of robustness. And those are contradicting each other, right? Innovation and standardization are things you cannot always bring together. The same goes for reusage and innovation. Or speed and robustness, right? The good old, I would say, before DevOps problem that operations always wanted to keep things stable, right? And development always wanted to introduce new things, right? Which of course was clashing back in the days already. And what you usually end up there, or what I personally see a lot these days, is that we build platforms in a very similar manner again. We say, hey, basically, come on, you can do everything. You can have your innovation, and we take care of the harmonization. And this is, of course, clashing. And if you talk to the platform team, they will tell you, yeah, I mean, you can have it in any color as long as it's black, right? What Henry Ford said back then. And a few months ago at another conference, I had a longer discussion with Gregor Hope. Maybe some of you know him. He wrote this book, Enterprise Integration Patterns, a few years ago, and now he's also very strongly into this idea of platform engineering. And he said basically, good platforms enable innovation by harmonization. So he basically says this shouldn't be, contrast. Harmonization and innovation can go hand in hand. And we talked for quite a while, and what resonated most with me was this idea of visualizing it in that way, that we said, usually we try to provide with platforms common things, right? So things that we can easily reuse, and on top of this, we build more specific things, right? And in the best case, on top of it, we just need to configure it, right? So low-code systems, for example, follow a very similar approach, right? In a usually very specific domain. But what looks good on paper there usually turns out to be an illusion in reality, right? Especially, if this fundamental project would need to anticipate a little bit more innovation, right? If you say, hey, I need to put a little bit out of the box things on this foundation, then things usually get quite tricky, right? So we could say we try to simplify things by making things reusable. And when we talked, it got very clear that we consider platforms usually a little bit differently, where we say, we have all this complex tech, which I showed you with the CNCN landscape, and we have a unified interface that basically allows us to build a ton of diverse applications on top of it, right? So what I want to transport with this visualization is that platforms enable diverse applications on unified interfaces. And there's a ton of good examples out there if you think about, right? HTTP, right, is a unified interface, and it allows us to build a lot of things on the web, right? Operating systems, right? Windows or Linux was created long before all these applications we have these days were even thought of, right? Linus Torvald didn't know that, a lot of crypto mining farms at some point in time will run on his operating system. So he obviously did a very good job in, this unified interface. And what stick that in my head in the talk with Gregor is that he basically said, if your user haven't built anything surprising for you, then probably you didn't do a good job in building your platform, which I think brings it down very, very nicely to the point, right? And later on, there was a longer discussion on LinkedIn. Maybe you've seen it or you've observed it. Probably it was also on Twitter. But in the end, we discussed this example of the car industry, where you have a very similar concept to say, hey, we have two parts. We have the head and the platform, and the head is basically the one which needs a lot of diversification, right? Needs kind of lower investments to bring out new models, and basically is the differentiator. And the platform is the one which needs standardization because it has high investment needs, and it basically is not the big differentiator, right? And I like this example very lot because I think it explains us very well how we should think about platforms, not just as reusage driven, but something where we say, hey, we have this unified interface that really abstracts away complexity beyond us. So we could also say we constrain the solution space without limiting the problem space. Right? That's basically the whole idea of this. And we see on the left-hand side that's usually not the case, right? We constrained the solution space, and by doing so, we constrained the problem space we're able to solve with it, right? Think of a UI kit library which we built in our organization, say, hey, everybody should use this now because it makes you so much faster, and economics of scale. But in the end, people are not able to build great stuff with this stuff anymore because it limits their problem space so heavily, which they can solve within this given solution space. So we could also phrase it like this, that the right-hand thing is more about economics of scale and the left-hand thing is more about economics of scale and economics of speed. Sorry for that. So platforms usually focus on accelerating the speed of delivery rather than the usage and standardization. And I think that's basically the main difference between what we sometimes consider as reusage and what we these days consider when we talk about platform engineering. And the worst thing you can potentially do in that sense is to say, okay, we have our application development teams and our infrastructure teams, and all we do now is we basically kind of rename this into a platform team. Because these teams, of course, have total different problems to solve, right? Where the infrastructure team, as mentioned, usually strives for robustness and standardization, the platform teams are usually striving for useful abstractions that make the application development teams more innovative. And of course, the split now sounds super simplified and is super simplified, but of course we also know that the split in infrastructure and application development is not working that well anymore these days, right? So you cannot put a ticket to a team to say, hey, I want to horizontally scale this thing now. This must happen out of the box. So the applications we develop and the underlying infrastructure are growing together much more stronger these days, which is of course, in a nutshell, creating the need for platform teams which are solving this problem from a different angle to say, hey, we basically enable innovation by useful abstractions. So when we do this by those useful abstractions, how can we find them? And unfortunately, I cannot give you the answer to this, how to find them in your specific domain, but I can give you a few examples which I observed over the last couple of years, how it's probably not working. So, as I said, we usually consider platforms in the domain of cloud-native infrastructure these days, because this is such a huge thing which usually no team on this planet can handle more on its own, so it needs some kind of abstractions. And what we often see these days that we build those platform teams. They start to say, hey, I abstract a little bit away Kubernetes. So you don't have a pod, you don't have a namespace, you don't have an autoscaler, you have a container. Or, you need database, okay, there you have a database, right? It's maybe a little bit pre-configured and it already has some defaults, and you don't need to know all the nitty-gritty details, but you still need to know that you need a database. And the same goes for Kafka topics, the same goes for dashboards, for monitoring, and the same goes for read models. And when you as a developer now need to deploy a new application, right, you basically need to compose all those things together. Right? You say, okay, need a container, need a database, probably also need a dashboard, probably need a read model for my Kafka topics to read from. So this is usually a very infrastructure-centric view based on composition. And that the based on composition is here important because composition and abstraction are two different things, right? We can compose different things to create things, right? Or we can put a layer of abstraction on top of things to hide a little bit of complexity. And that's basically what you want to achieve, right? You want to achieve a developer-centric view in that case, right? Your customer is the developer, right? He doesn't care about the infrastructure you're having in the background. He cares about saying, I want to deploy a new application. And maybe I care about if this application should be stateful. Maybe I care about if this application should just be a simple event processor, taking one Kafka topic and producing an event to another one, or it's just a cron job that runs every 2 hours to do some tasks like this, right? And the developer then needs to decide on the right abstraction for him, but doesn't need to compose things anymore in that sense as we've seen before, right? Again, fully agree. Of course, a super simplified example, but me, it helps a lot to think, hey, am I actually just doing an abstraction here, or are we doing here just a composition? And I also think that these compositions help a lot, or these abstractions instead of compositions help a lot for a common problem we see when we talk about platforms. And this common problem we see when we talk about platforms is something which we tend to call a thinking platform. So platforms are usually not built up from scratch, right? Nobody from us says, hey, I built a complete new platform, right? In the cloud-native space, I showed before, they are usually built up on platforms from hyperscalers or even from multiple hyperscalers. So you build your internal developer platform on top of AWS or Azure or GCP, whatever you're using in your organization. And those platforms, those base platforms are unfortunately, evolving, or not unfortunately, fortunately evolving over time. So they get a lot of new features. They maybe even take features which you've built in your own platform. So you kind of need to figure out how can you stay on top of this base platform so that you do not become a singing platform, which we tend to use as a phrase for platforms that hinder us to basically use the features of a base platform. And that's usually due to leaky abstractions, right? If we say, hey, you want to have a database, okay, we are on AWS and we have a Cosmo, or we have a DynamoDB in place, right? And you just expose a DynamoDB to your developers, then of course, the abstraction is very bound, and you will probably have issues in bringing in new features that AWS maybe brings as a better alternative for a DynamoDB, right? So potentially it makes sense to think more about, okay, if the thing is called the same thing, then it tries to abstract away, then maybe my abstraction is not good enough, right? Because what you of course want to have is you want to have these floating abstractions, these floating platforms, which you usually just achieve by finding the right abstractions, right? And as I said, I don't want to simplify this topic, and I don't even want to say that it's always feasible, but I strongly believe if we want to do platform engineering with additional value for our engineers, then we should do it in a way that we find the right abstractions. And finding the right abstractions, again, is super hard, right? As I said before. And it takes a lot of time, it takes a lot of effort, and it takes a lot of knowledge. And when you then take a look at those platform teams usually and ask them, hey, how did you came up with what you've built now? How did you basically validate that it makes really the developers in this organization faster? Then it's always usually very hard to figure out with them, because in many cases those platform teams, they are composed of 2 infrastructure engineers and 3 DevOps engineers and maybe 1 cloud architect, and that's what they consider as the platform team. But I work a lot with startups also these days, and if you see a startup which tells you, hey, we have 6 people, and 5 of them are engineers, and we have an additional architect maybe, then you would say, not sure if you will be successful in that setup, right? You probably need somebody who promotes the idea, who kind of, do some stakeholder management, who analyzes the market, all those things which you need to have to build a useful product, right? And I think that's one of the things which we could easily fix to shift a little bit the mindset there. If we really build platforms, then we should consider them as products, and we should treat them as products, right? Where we say, hey, our customers are obviously the application development teams that hopefully benefit from what we've built, right? And that's usually easy to fray thought, but of course it's very complex to bring this in the mindsets of an organization, especially with what I said before, that we often see just infrastructure teams now being mimicked as platform engineering teams. And I think that's a problem because it washes out the term again, and it makes it very hard to see what's really the value of those platform engineering teams. And it usually keeps companies keeps companies unhappy back, right? We say, hey, we follow this new thing now and everything is like it was before. It just has a different name, right? So I think considering your platform as a product and also stuffing it like this is key. And there was at the Code Crafts a few months ago a fantastic talk from the product owner of the platform at Bumble. So she talked about what is so hard to build internal products and internal platforms. And I think there was a value in there that she basically just said that the most important thing is that you, first of all, think about your customer, right? And I think that's what we really often miss, right? We often consider it as, okay, what we want to enforce is reusage and harmonization, which could be a fair goal, right? But probably not the right tool in that case would then be to do some platform engineering. So to also have some time for questions, I would like to sum up with what I tried to convey in this talk. So I think it's important to understand that when autonomous teams are our organizational scaling strategy, then the mental load within those teams is our biggest obstacle, right? And platform engineering is probably your most promising ally in overcoming this obstacle, right? And I tried to give you 4 simple examples which I think are very important if you want to succeed with this. And the first one was, as I said, platform engineering is more accelerator, right? It's more about increasing speed than basically increasing reusage and standardization. And there's this metaphor of this golden path or this fourth path, right, where you say, hey, platform should basically provide this power street where developers are much faster than if they just, go left and right. And sometimes I see those streets, but I see them more like a cage, right? There was everything built around that you cannot get out of the street, but the street itself is very dirty and muddy, right? So I think we really need to focus more on how do we get this street up to speed so that people who, go along the speed are really fast and don't want to even leave it because there's so much acceleration in that platform. And I think rebranding our existing infrastructure teams is something I see quite a lot these days, and I work with a variety of organizations on topics around that. And I think this really is a big problem because usually classical infrastructure had total different problems to solve than what you would like to solve these days, usually with platform engineering. And great platform APIs, from my perspective, are always bound to great abstractions, which leads to the fact that you need to know a lot about the organization. You need to know a lot about how those people in this organization are working. What is the service for them? What is the API to the developer which you want to provide with your platform? And last but not least, treat your platform team as a product team, right? And of course also stuff it like that. Thanks a lot. I hope this was useful.
Thank you, David, of really good and important stuff. I just want to add one remark, and that's related to the old traditional way of platforms and why it's so dangerous to just, put another label on the existing stuff. Usually in former times, platforms were also not only done for standardization, reuse, and robustness, they were also done to save costs. Yeah? And the new way of thinking about platforms is not like reducing costs, because if you properly staff them, and it's like probably getting more expensive. So the transition from the old to the new is not made easier by this fact.
Yeah, I think that's a very good point, and that makes this topic usually so hard in our industry, because the cycles in which, in the end, a company has two goals, right? Either to reduce costs or to increase revenue, right? That's the two situations which you are in usually. And if you want to reduce costs, like we've seen now in the last couple of years quite heavily, then of course harmonization, standardization, bringing things together makes a lot of sense, right? Because it saves costs, right? But a couple of years ago, when especially in the VC market, money was I would say very easy, then it was totally the opposite, right? Then we said, hey, we need to be fast on the market, right? And we need to strive for autonomy, and we need to give all those teams a credit card to go to AWS to buy whatever they need, right? Which led to this overload in cognitive load, but also, as you said, is kind of the different part of the coin, or the different side of the coin, yeah? So all these things are super simplified, right? I think that's important to mention, right? So I'm a consultant, it depends usually, and I fully agree that you always need to understand what are you striving for. And if you strive for faster innovation, faster pace, then I think platform engineering is really a handy tool for you. If you strive for saving costs, if you strive for harmonization, reusage, and thereby saving costs, then I think classical infrastructure teams that kind of say, hey, you can use those 5 tools, right? Because we get then, economic of scales. If everybody using an Oracle database, Oracle gives us a better price, right? Then of course this makes sense, yeah. But thanks for the input, yeah.
Thank you. Thank you for the speech. My question is more a question of understanding. If I got it right, the idea of a platform team, as you, make it quicker or make innovations be delivered quicker. I understood this is the let's say the aim of the platform team. I first thought platforms are very generic. There is no specific domain know-how in it. It's very generic features that basically any company could use. But then I later thought, okay, if the aim is to make the streamline teams or the feature teams or the innovation teams quicker, how much domain-specific things could be or should be in a platform team?
Yes, yeah. That's a question which has no yes or no answer, unfortunately, right? I think I tried to explain this here. Why do we actually need additional platforms, right? We have so well-designed platforms out there, like the AWS platform, which is totally generic, or has the goal to be very generic and domain agnostic. But in many cases, as I said before, there is, I would say, a technical domain language in organizations, right? If you build a service, or if you build an application organization B, this service looks completely different than if you would build an application organization B, right? So you have different integrations which you need to take care of. You have different authentication, authorization. You have different logging and monitoring tools out there, right? And of course, the idea is to build a layer or an abstraction on top of this, which is specific for your organization. And this could be a very useful or a very powerful concept. And people in the platform engineering community usually call this the API for the developers, right? And the API for a developer in organization B usually looks totally different than the API for a developer in organization C. Because they do different things, right? They have different constraints. Maybe the one organization needs high scalability. The other organization needs to still work on on-premise infrastructure and things like this. So I think this is usually the differentiating part between generic, general available platforms and your specific platforms for your specific developers in your specific organization. And one last sentence to add is, I think So we at Square usually say platform engineering makes sense in organizations with 120 plus engineering organization. So it does not bring you much value if you say we have 12 developers and now we start platform engineering, right? The real big advantage comes if you have 10, 20, 30 teams where you can then really take away cognitive load and find out, hey, what is the thing that makes this team really faster? And we usually, as I said, don't do this by reusage, but providing abstractions on things that are complicated. And this is usually technology. Hope this answered your question or made it a little bit clearer.
Thank you for your presentation. I have a bit a different question. We have also in my company platform team, and they are doing a great job making this abstraction for us. I'm coming from the developer team. But we have one dilemma. So the platform team grew out from the operation team. So they were operators before and now as well. So they also have this responsibility still to take care of the applications even in the night and if when somebody calls and so on. We are taking care of the Austrian e-card system. So so they're helping us to get autonomous so that we can work independently, but we still cannot do it because we don't deploy in the production. We can deploy into the old test systems, and then we had to give our applications to them to explain that we want this, that, please deploy it, and then take care of it if somebody calls.
Yeah.
Call us just if there's a real emergency. And we cannot take over this big responsibility with getting woken up in the night. Do you have some experience in consulting other companies? How did they overcome this difficulty?
Yeah, I see this constantly, this setup, right? That infrastructure teams which still take care of 24/7 operations, also building now platforms. And I don't say that this is per se a bad thing, but I think it makes things a little bit difficult, right? Because by default, and I think that's deeply rooted and I also consider myself as somebody who works a lot with cloud-native infrastructure these days. If you ever operated a Kubernetes cluster or a Strimsy cluster or whatever it is, right, you at some point in time come to this attitude of, never change a running system, right? Which is from an application development perspective very bad, because if you never change the running system, then probably, you will be gone at some point in time. And I think it really needs very good people to kind of have this mindset and find this trade-off. How can I still provide a lot of innovation, but not always shoot myself in the leg? And I think there's a lot of technology out there that can help us solve the problem, right? I think you need to invest in a lot in how can I make dynamic rollbacks, how can I increase the certainty for these operation teams if they make changes on the platform, that it doesn't kill their own infrastructure, right? I see this as a very challenging problem, to be honest, or as a very challenging setup, because as I said before, also with this image, I tried to show this, that there are clashing constraints, right? And so I'm more a fan of saying, hey, we have platform engineers, we have site reliability engineers, and we have application development teams. And if we need 24/7 support, then the site reliability engineers work with the teams closely to enable them to do this. And on the long run, the teams should be on their own able to do this. But I also fully understand that that's not always possible in all organizations, right? So in the end, you need to find a trade-off that fits your needs, unfortunately. Yeah. Welcome.
So maybe not an easy question to answer in 5 minutes, but going from a service vision to a product vision is a hard paradigm shift. So how do you communicate this to management? How do you sell this? How do you go from providing a necessary service, and everybody needs that, so no questions asked, to discussing about the features and necessities of a product?
Mm-hmm. I think that's a good question. So in a nutshell, I think platform engineering teams usually have a hard stand in showing their value, right? Say, okay, we take care of our key cloak, we take care of this and that, and everybody uses it, but nobody gives us credits for doing so, right? And management just considers us as an additional cost in our whole engineering organization, which doesn't, bring a lot of additional customer value. So I know this problem. I think the solution lies in considering the platform, as I said before, as a product on its own, and this gives us usually methods to show the value of such a platform. So, for example, a lot of organizations doing at least lightweight net promoter scores these days. So, if they're building platforms, they ask the development teams, how likely would you recommend this platform to another team within our organization, right? So they really treat them as a product and their customers as developers, right? And of course, at some point in time in organizations like this, you need to start to distribute the costs, right? You probably need to say, hey, if you want to use this platform, you as a stream-aligned team need to pay for it, right? And I think then it gets really interesting, because then I would say that the monkey jumps into the water, right? And you see if this platform is really good enough that people would use it if they would need to pay for it. And I think this is very important, that you get into this competitive market, right? If the team says, no, it's much easier for me to put things together on AWS and it's cheaper, then I think it's fair for them to do this instead of using your platform, right? So the platform needs to be liberated in a way that people don't need to use it, right? In a way that people obviously want to use it, and then I think you have a much easier standing against the management to tell them, hey, you see, if this is shut it down now, developers would really be sad.
Thank you, David, for that great talk. As a product owner, I have also a transitional cost-related question, but from the other direction, from the customer teams, so from the application feature slice teams. Could you share some learnings of your several years of introducing this concept? How to be efficient on the transitional side, on the training side for feature teams?
Yeah, costs are an interesting factor in this whole thing. I didn't go much into detail about this, but they of course are an incentive, right? So you can create a lot of incentives how you ultimately make the pricing structure for your internal development platform, right? So, for example, if you want, so usually you have, like in any product, a certain tipping point. Let's take the example of data platforms. We build a lot of these data platforms these days, and usually data platforms are completely useless if there's no data on it, right? But they start to become useful if there's a lot of data on it, right? And if you need to pay now to put data on something which is not for use for you, then of course your pricing is probably not I would say setting the right incentives. So in these situations you could potentially say, hey, we give you the upload of data for free, right? And if you want to kind of analyze it, then you have to pay as a team, right? And even if you upload more data, you kind of get free credits to get analytics for free, so that people are really incentivized to put data on the data platform. And this is, I think, a really tricky problem, and you need to think a lot about it. But I think you should not keep it out of the focus, right? I know that a lot of platform teams start to say, hey, let's keep this topic for now. We do this as internal costs, and we try this out now. But at some point in time, you will have this discussion, right? And I think you cannot start early enough to think, hey, what is really our value, right? And what are our customers, in that sense, development teams are willing to pay for that. And as I said before, I'm a big fan that an application development team doesn't need to pay for it at all. If they say, hey, I don't want to use it, it doesn't bring us value. We are an autonomous team. We take the infrastructure directly from AWS, or we operate it on our own, or whatever we do, right? As long as we take then also the responsibility for the costs, for the SLAs, for all those things. And I think that's usually a dilemma if you're somewhere in the middle of this graph, right? Where you're kind of have this split responsibility of you build it, you run it, right? And I constantly ask at conferences how many organizations really do you build it, you run it. And in Europe or in Central Europe, it's quite a majority, because people just don't want to have on-call rotation. I fully understand it, but this, of course, leads on this graph to the fact that you cannot also have all autonomy as a team, right? So responsibility always comes with autonomy, accountability always comes with responsibility, right? So if you want to have complete autonomy in your team, then you need to obviously take complete responsibility, which is usually hard to achieve. So you find yourself somewhere in the middle and say, hey, we have some play rules, right? You can select whatever frameworks you want, but in the end it must be a Docker image, or in the end it must be deployed like this and that, right? So that we can in the end also monitor and operate it for you. Yeah. I hope this was the answer to your question. Forgot the question in the meantime.
So thank you, David.
You're welcome.
As each speaker gets a chocolate from us. Thank you
nice.
that you was here, and thank you.